Hello everyone, this is Vahe. As promised, this is an introductory video for the first experiment, which is based on Matlab. So let's get started. As I mentioned in class, Matlab is available on all school computers, in the library, in SEL, as well as the computers that you'll have in the EC115 lab. Okay, so on the ECE webpage, EC115 webpage, you'll see information about the laboratory, some of the particulars about when we'll have labs. Basically, we'll have labs all the way through. First 2 weeks, obviously, we didn't have any labs. Next week is week 3, so we'll be starting our labs. And I've already put some information on Blackboard regarding experiment number 1. I'll say more about it if any more information is needed. But right now, I'm just going to concentrate on the what's in experiment 1, which is Matlab, right? As I said, Matlab is available, so I'm going to assume that you double-clicked it and launched it. And when you do, the Matlab window will look something like this. So you'll have these several windows in there. Typically, you'll have 3 windows. The window in the middle is called the command window. This is where you're going to type in your commands. Workspace that shows your variables and what their values are. And a current folder, which is also called the working directory or the working folder, which points to the working directory, which has your particular Matlab programs, if any. That might just be empty. But basically, the current folder shows the contents of the directory that's shown on top over here. So right now, mine is pointing to a folder called EC115 on my desktop. But as you launch this, as you launch the Matlab program, it's going to point to wherever else. You can certainly change this to anything you like by using the little icons over here, but typically we just leave it alone. But you can point it to anywhere you like, basically. And if there is Matlab content in there, it'll be displayed here. Typically, like I said, most of the time we're going to be using this command window in the middle, because as I said in class, Matlab is just a very fancy calculator, and so it has a programming language in there too, very similar to the programming languages you may have seen or you will see. But our interaction involves typing things in this window. Now you can change the layout. So this is the default layout. And so if you go to this little icon here saying layout, obviously, click on it. And so we can use, for example, what's called a 2-column format. And this might be a little more a little easier for us, at least for me to show you, because I'm going to be typing things and I don't want to run out of space on the line for your visualization, basically. But if you do not like this, you can always go back and go to the default, which is this, or try to come up with a structure or a layout that you like and then save it, etc. But typically this would be enough. So let's go to the 2-column format and go from here. So basically, once you have the command window, you can type in anything after these greater than symbols. There's 2 greater than symbols. So you can just use it as a calculator, and when you do, all the typical addition, subtraction, multiplication functions are already there. Like, for example, if you do 2 plus 3 and hit enter, you get 5. And the typical variable that, or the default variable that Matlab uses is called ANS, which is answer. And right away, you see that the ANS value is equal to 5 on the lower left-hand side where it says workspace. So unless you give it a variable, it's going to call it ANS. And if you do another calculations, for example, 3 minus 6 or something like that, it's going to keep overriding that ANS value. So if you want to keep track of your values, you normally assign it to a variable, like let's say x. So you say x equals 9 times 5 or something like that. And then you press enter, and now x is equal to 45. If you were to go ahead and call x something else, and you can keep overriding that x value, so you might want to assign a different variable if you like. right? If you want to repeat the old commands, if you want to go back to the old commands that you kept on entering, if you hit the up arrow, you will see your old commands. So whatever you were working with before, it'll all be in there. So you can go back and repeat the things that you did before. So that's another thing that you can get. You should be familiar with so that you don't type in everything each time. But we can keep typing variables like this. Y equals 7 divided by 5. So all the commands are there. Addition, subtraction, multiplication, division. I just did division, but you can also do division this way. You can say y equals, for example, 5, and then /6. I mean, that's something you might not have seen, but so it's going to put 6 on top of 5, so it's going to give you 6/5 actually. So that's something Matlab also allows. Right? Looks a little weird, but you can think about it. If you think about it, you'll see that it's 6/5, 6/5. So 6/5 gives the same thing. So this is just a normal operation, as you know. Matlab also has built-in functions. So I'll talk about the trig functions, sine, cosine, tangent. It's got those built in, but it also has the constant variables. For example, pi, right? So pi is built in. If you type in pi, press enter. So that's pi, and we can display more digits as well if you like. You do not want to use a variable name that's already been used as a built-in function, right? So if it's a built-in function or a built-in variable name, you typically don't want to use pi equals some variable that you like. You should use something else. Otherwise, that variable will get rewritten, or you might not be allowed to actually use the variable. So we have these built-in functions. We also have exponentiation. So if you want to do, let's say, y equals 7 squared, right? So use this up arrow, which is called caret, C-A-R-E-T. Right, most of you know this from your programming courses, if you've taken any. So this is typical, just a normal calculator. And then, for example, let's say you want to find a sine of 45 degrees, right? You do something like this maybe, but you might be surprised to find that you don't get the right result, right? So sine of 45 degrees should be square root of 2/2, which is 0.707. So what's wrong here? Well, one thing about trig functions is that they really, in Matlab, by default, they expect angles in radians. So what I just put there, I said, what's the sine of 45 radians? And as you know, 360 degrees is 2 pi radians, right? When we talk about 180 degrees, for example, that's pi radians. So 180 degrees and pi radians is the same. You should know this from your geometry or analytic or pre-calculus or analytic geometry course probably. But that's something that's a default. So if you want to enter a 45-degree angle, get the sine of it, you can instead use SIND. So if you use the built-in function SIND and then 45 degrees, right, like this, then Matlab will give you the right thing. Okay. Now, nice thing about Matlab is that it's got a lot of places where you can enter you can ask information like help information. So if you say, for example, help and the function name, I'll illustrate this a little later. Help function comes up, examples comes up. So it's got built-in documentation, and that's how you learn Matlab. You try something, maybe it doesn't work. You look at the help, and you go on for you go forward. You learn from as I illustrated in class as well. Okay, so the functions with the d at the end, like sine d and cosine d. Like for example, if you say cosine d, what's the cosine of 90 degrees? Or let's pick something else like 30 degrees, right? You can use it this way, and you get 0.866. That's square root of 3/2. That's correct. But if you had said cos 30, I mean, what you're really doing is you're finding the cosine of 30 radians, and that's also correct. That's also correct, but you gotta know what you're putting in. Okay, so you got sine, cosine, tangent. And remember that you can convert from radians to degrees and back and forth by using the factor 180 over pi, right? So if I wanted to use, if I wanted to find, if you just wanted to find the cosine of 30 degrees, I could have done this, right? So instead of entering cos 30, I could have entered in cosine of 30 times pi over 180, right? So here, pi over 180 is the conversion factor, right? So 30 degrees is actually pi over 6. That's what that factor is giving you. Pi over 180 is kind of the conversion factor. So this will give you the cosine of 30 degrees. So it's as if I typed in cos d 30, right? You get the same thing. You get the correct expression. So this expression here gave me the same result as this expression here. So you can look these up, just like you can say sine d, what's a sine of 78 degrees, right? So there you go. D stands for degrees, obviously. But the default is radians, remember that. Okay, we also have you can use arc cosine, arc sine, like inverse sine, inverse cosine function. Those are also available. Like if you say, basically if you say, what's the angle whose sine is 0.5, something like that, you get 0.5236. But remember, that's actually in radians, right? So it gave you the angle in radians. If you wanted to take this number and convert it to degrees, you would take that number, right, and then do 180 degrees over pi radians, right? So ANS is a built-in variable, so I can type ANS, right, ANS times, right, 180 over pi. So that's 30 degrees, right? So the angle whose sine is 0.5 is 0.5236 radians or 30 degrees. Well, I could have probably done that if I use a sine d, right? So there's an a sine d. So let me go back to this and just put a d here, okay? Well, I could have gotten the 30 degrees directly like this, right? So if you look through, you'll find these kind of things. And you'll you can use it as you wish. Okay, so just knowing a little bit about these things is useful. Okay, so what else? Well, other things is the way the numbers are displayed can be changed, and that's what this format function is giving you. Format function allows you to change the the way that the digits are displayed, if you're going to use scientific notation or other notation. So that's through the format function. If you say, for example, if you say format, okay, and you don't say anything after that, or if you say help format, for example, let's just do help format to see what you get. You're going to get a lot of stuff. You're going to get different kind of all kinds of information about. There's all these things called format short, format long. So once you type these in, the following calculations will have a slightly different format. I'm using the default. So I'll show you how that is just by one illustration, but you can read up and you might be experimenting with it a little bit in the lab as well. But let me illustrate some other things. Like, for example, I have all these variables already in my system. For example, A and S, X and Y are variables in my system, as you can see, lower left-hand corner. Well, suppose I want to clear them out. Well, you just use the word clear. And now those variables are cleared. So that clears the variables and also the functions that are in there. And there's another command that might be useful. That's called the clear command. Okay, the clear window command. So if you say CLC, it clears the window and brings you to the top of the window there. So this is like a way to start fresh from the beginning with a clean sheet of paper. You can think about it that way. So let's just look at some other functions. Like, for example, square root, right? So if you say square root of 3 you get square root of 3. Square root of 2, right? 1.414, etc. Right? If you say square root of minus 1, right? That's allowed actually, and you get 0 plus 1i, so you get I. Or in electrical engineering, actually, we use J and not I, but MATLAB understands square root of minus 1. So if you say J, actually, it understands as I. J and I are our way of denoting complex numbers. The reason we don't use I in electrical engineering because I is reserved for current. That's the only reason. But other than that, it works exactly the same way. So suppose you wanted to find out about the square root function, right? You can just say help, SQRT, and here it is, right? Or you can go to the top here and top of the window and type in SQRT, and a lot of things will come up, including just the good old square root function. If you click, you'll get the MATLAB documentation. So you just, this is just built-in documentation. Scroll down and read it, and there might even be examples or other illustrations. But anyway, things are here for you to, consult basically. All the functions are well documented this way. So that's a square root function. For example, let's use the another function. Let's say hyperbolic sine, SINH, right? Hyperbolic sine of, let's say, 10. You get the number. It's a huge number. SINH, right? Let's say SINH 1, right? Don't know what this hyperbolic sine is. You just say help, right? Help, hyperbolic sine. It tells you it's a hyperbolic sine. Okay, it doesn't give you anything. Maybe you go up here and you say, okay, SINH. Oh, hyperbolic sine. Click on it, and you can read about it. You can read about it. There's a plot of it, etc. So this is very good to use. Very informative. I'm just illustrating it to you so that you're aware of it, and this is the way you learn about different functions and different features. Okay, so I encourage you to do so, because knowing this tool is just a matter of just basically exploring what's there and asking the right kind of questions. Okay, so let's do a little CLC and do a little clear, right? And here we go. So what else? Well, let's talk about, let's say, natural log, right? Natural log in MATLAB is log. So if you say log, that's actually natural log. How do I know that? Well, if you just do help log, you'll see it's actually a natural log. So it's ln, right? So ln of x is done by log. So if you say log of 4, right, you get the natural log of 4. If you want to use base 10, right, log base 10, you got to say log 10. So if you say, for example, log base 10 of 100, you're asking the question, what should I raise 10 to, right? What should I raise 10 to get 100? That's 2, obviously, right? So you press, and there you go, right? So how about log base 10 of 1000? Well, that should be 3. 10 to the 3 is 1000, etc., etc., right? Another built-in function. So there's a ton of these functions. Pretty much all functions that are built in. What else? Well, as I said, MATLAB stands for Matrix Laboratory. So the basic building block in MATLAB is actually a matrix, right? Which is an array of numbers. When we're talking about the symbol numbers, like the numbers we've seen so far, those are basically one by one arrays, and you can see that by just looking at the lower corner here. Everything that we've typed in so far, they've all been size or dimension one by one row, one column, which we call scalar. Any other dimension that's greater than 1 by 1 will be a matrix of some sort, and matrices typically are rectangular and have a bunch of rows and a bunch of columns. So we can actually enter those in MATLAB pretty easily. So let me show you how to enter in what we call a row vector or a row matrix. So let's call that matrix X, okay? So let's just clear everything. Do a CLC and start from the top. So let's say I'm going to declare this array of numbers called X. So we say X equals, you open the square brackets, and you just start typing in numbers with spaces. 1, right? 2, 3, 4, 5. And you press enter, and now, Matlab echoes back, shows you exactly how X looks like. So we call this a row matrix or a row vector sometimes. When things have when matrices only have one row or one column, they're referred to as vectors. So this is referred to as a row vector. And you can see down here that in the workspace that X is 1 by 5. So the first number is the row, second number is the column. So it has 1 row and 5 columns. We can do the opposite actually. We can actually do a column vector. So let's make a column vector. So let's say y equals, and let's enter in a column vector. Again, you open the square brackets, and then you type in a bunch of numbers. So let's type in 2, okay? But now we have to go to the next row. The way to go to the next row is put a semicolon. So 2 semicolon, 3 semicolon, 4, right? 5, 6, 7, 8, 9. You can keep going, and then when you're done, whatever the dimension that you need, right? Press enter, and now that's your column vector. And you can see right away why it says 8 by 1. So 8 rows, 1 column. Another way to examine the dimension of a vector or any matrix actually is to use the size command. SIZE X gives you that X is 1 by 5, and SIZE Y gives you 8 by 1. Exactly what's displayed over here. So these are very, very important things for us to they're just way to keep things straight in case you forget. When you have 2 or 3 things, it's pretty straightforward to keep in track. But if you start getting 30, 40, 50, 100 of these things, this is very important. Okay, so we can also obviously make any size matrix you like. Let's call A, for example. Let's say A equals, you open the square bracket, and you say, for example, 1, 2, 3, colon, and then 3, 4, 5, close, right? So that's, obviously we have 2 rows and 3 columns. It's clear, it's also in the workspace. And then if you say size, right, if you say size of A, oops, I pressed enter without completing the thing, the expression, so it gave me an error, but that's okay. I didn't do anything wrong. I just didn't press A yet. Here we go, 2 by 3, right? So sometimes even by the errors you can determine, oh, I did something, or I missed the parentheses. Matlab errors can set you straight. So as you can see, A is a 2 by 3 matrix, right? Okay. All right, so we can also use these vectors for other things. For example, when you're plotting 2 functions, or when you're plotting a function, typically, let's say a normal graph, we're plotting x versus y, for example. Well, you typically do that by picking points in x and then calculating the corresponding points in y and then doing x versus y, right? So that's typically what we do. So let's talk about how to generate an array by hand, right? Sort of manually. So let's clear all this. So let's say clear and then CLC. So we're starting from scratch again. So let's say we want to generate a bunch of numbers, right? MATLAB actually allows us to do this with the colon operator. So let me just show you that. So if I say x equals, okay, and if I say 0 colon 0.1 colon 1.0, for example, it'll generate an array of numbers. Let me press enter to show you what it gives. So it generates basically 11 numbers, and it's actually x is actually a vector right now. It's an array, and it has 11 elements. It's got 0, 0.1, 0.2, 0.3, all the way up to 1. So what this is that the command is your starting point is 0, your end point is 1.0, and over here the middle number is the increment or the step. So this is saying generate a variable called x starting at 0, ending at 1.0 using steps of 0.1, right? So this is actually very useful. But as you notice, every time I type in something, MATLAB echoes back what that variable is. And it's not a big deal in this case, but let's say I generated a lot more of these, right? So let's say instead of going to 10, instead of going to 1, I went to 10, right? Then I would have 101. If you scroll through, there's a lot of numbers there. It's kind of annoying, right? So see all these things at once. And if suppose I did like 1,000, imagine I went and said, okay, I want steps of 0.01, right? Press this, and I just generated 1,001 points. You can see from here that it's that x is 1 by 1,001. One row, 1,001 columns. Well, if I don't want it to, if I don't want the MATLAB to give me back this echo each time, what I should really do is I should go back to my command and end it with a semicolon. Okay, press enter, and now my values are still stored as they are, but I don't get that echo of all these numbers going by. So this is actually very convenient. Let's just do a CLC to go to the top of the screen here. Okay, so now I have x 1,001 points, and you can use this to generate all kinds of things. So let's use x to generate. We're gonna actually I'm gonna show you how to plot something. Okay, plot a sine wave, for example. So what we'll do is we'll first generate x values. So I'll use this. So I'll say x is equal to, okay, I'll say 0, and then I'll take steps of pi over 100, and then I'll go up to 4 times pi. Okay, so it's going to generate a number of points for me, and so the starting point is 0, end point is 4 pi. You'll see what this is in a second, but I'm going to do this. Okay, press enter. And I just generated a 401 point row, okay, 401 point row vector. So it's got one row, 401 columns. Then I'm going to generate a sine wave. So I'm going to say y equals, okay, sine of x. So for each value of x in that vector, it's going to generate a y value. So y should have the same size. Okay, press enter. Y has the same size. It's also 401 points. Now what I'm going to do is I'm going to simply plot x versus y. By the way, I mean, x and y could have been numbers that you got from an experiment or something. You can just type them in or get them from a spreadsheet or other kind of information. You can plot x versus y. So, but we're artificially generating them here just for purpose of illustration. So we say plot x comma y. Okay, you press enter. All right, and what happens is you get this plot. Okay, so this plot appeared, and we're ready to use it as is, or we can actually do some more things. So let me illustrate what you can do more with this plot. And by the way, I mean, obviously there's these menu options. You can do all these from the menu, but I'm going to illustrate the basic things that you can do just by typing things in over here. So let me resize the windows so you can see both windows at the same time. Okay. All right. So now that our plot is up, what I can do is I can say grid on, grid on, okay? And now you see the grid, and you can say grid off. I think I showed you this in class as well. So you can say grid on, and here we go, right? And I can say, for example, maybe I want to give some labels to the x-axis, y-axis. Maybe I want to show a title. So if you want to put in a label for the x-axis, you say x label, okay, and then in single quotes you put x. By the way, notice that when I put some kind of a known keyword or a function, all of a sudden I get this window that tells me what I can put there, right? So it's giving you some hints on what you do, right? So the help is like live, basically. Help is live. But I know that I can just do this, so I can just go on and X label, press enter. You should see the X on the X-axis. I could put anything I want there, by the way. I could say time and T or any word that I use. Anything between the single ticks, the single quotation marks will be put in there because it's a text value. So X label, now we have Y label. You know, maybe I say Y. Okay, like this. So I have Y. And then the title, T-I-T-L-E. If I can type actually, would be nice. Single ticks, and I can say maybe plot of y of x equals sine x, and then close the quotes, close parentheses, click, and you got it. So that looks nice, right? And now you know, you can print this, and typically though you can actually put this into a document, and the way you can do that is you can say from here edit. If you say copy figure, this gets copied to the workspace or the scratch space in Windows. And let's say you had Word open, if you just say paste, there's your plot right there. Right, so this is a very easy way to include plot in reports. But typically in our labs, you might be asked to just sketch it because we want you to sketch the functions by hand to learn it. But if you're writing a long report and you had a lot of these things, you typically use something like this. You copy and paste the figure into your document this way. This is a good way to document what you're doing. And you can paste it into anything. I mean, it doesn't have to be a word. I'm just showing you this. Okay, now the other thing about Matlab, of course, is that if you notice, suppose I quit my session, right? Well, all these things will go away. So let's say I close this function, and let's say I had cleared the screen, right? I would lose all this. So if I say, hey, this is a good this is giving me the function I exactly want. I want to be able to recall these commands. That's when you should actually save this into what's called a script. Script is basically a little program that has these functions back to back to back that you can replay later. So here's a way to do it. So if you go up here, you say new script. Okay, if we say a new script, Matlab will open up a little editor window for you where you can type in your program. But since we already typed everything in down here, what I want to do is go here, and I just want to go and copy everything we have over here, and you just do a right click and say copy, okay, and come over here inside and say paste, okay, or Control C, Control V, that'll work too. So now all these functions are okay, but I don't want to turn grid off, so maybe I delete this part maybe, or whatever you want to have there, but this will pretty much do it, right? Declare the X, declare the Y, plot, put the grid on, X label, Y label, and the title, we're done, right? And then maybe I want to put a little comment, and comments can be done, by the way, by just putting in the percent symbol, and after the percent symbol saying, plot. So this is not a command, it's just a comment for me, and anything after a percent sign is considered comment. And Matlab knows about this, so it's printing it in green. So a plot of sine x. Let me just do a little command. So this tells me, what this program is all about. I can put comments all over the place, but so this is not a command that MATLAB will execute. It's just there in the file. So what I'm going to do here, I'm going to save this as something, okay? As long as I don't save it as a built-in name like sine, cosine, or something. So what I'm going to do, I'm going to say save as, okay? And I'll say, and notice that it opened up the save command in the working directory that I told you in the beginning, right? So I'll say, for example, like plot sine wave or something like that, naming anything like that, .m. .m is recognized as a MATLAB file. Save it. So now this has been saved, and right away you should see that it's actually being saved to that directory. It's called plot sine wave. Now the nice thing about this is that because this is saved, I can close it, right? And let me also go, so I'm back in the command window. Let me clear everything. So clear, and then also CLC. So now there's no X or Y at all, but I can recall my function very easily by simply using the name of the file without the dot, without the M. So if I say plot sine wave, okay, my window pops up like that. Okay, so if you have a lot of commands that you worked on and you typed it in and you got something that actually works or something you like, you can save it this way easily and then just run the command to just have the commands basically, it's as if you're typing in the commands one by one, back to back. So this is a good way to document things. Right, and then if you want to open this up, of course, if you go to the file and you double click it, okay, the script comes up, the editor window comes up. You can edit it and see it and save it again, or save it as a new file and update it and expand it, etc. Okay. Anyway, I can go on and on and on about this, but I just wanted to give you a short description of the kind of things you can do, just to give you a taste of the kind of things that you could do. There's a lot of information here. There's a lot to learn, but to get started is actually quite easy, and you have to get started little by little. You can't do it all at once. So you just learn little by little, and you have to learn by doing it. I mean, just watching me is really not enough, as I mentioned. That's true with everything. So I hope you find this useful. I hope this prepares you for the lab. So if you watch this video and you look over the document, I think you really should be ready for the lab. The lab should be a piece of cake. We have 3 hours, but I don't think you really need 3 hours. I just ask you to, give me any comments that you have. So thanks very much for your attention. I hope you had a productive first 2 weeks, and I hope the rest of the semester goes well. So I will say goodbye for now, and I hope to see you in another video very soon. As always, please subscribe to my channel, or just come to class. Actually, that'll do it. You don't have to really subscribe to the channel. But anyway, goodbye for now. Over and out. I will see you next time. Thank you.